Welcome to this edition of Coatings Decoded. I'm Jack Walker, and this week we're going to look into some challenges that have evolved over the years in protecting our wastewater infrastructure. We're going to introduce some next generation ceramic epoxies that are changing the game as how we deal with this problem. So our guest today, you know him, you love him. He's the mouth from the South. I like to say he's number one in the number two business. I'd like to welcome our Director of Water and Wastewater Products, Mr. Brian Cheshire. How are you doing, sir?
Doing well, Jack. Thank you for that very kind introduction. That is way more than I deserve.
Well, I always try to give you like the Apollo Creed level, and I think by the time, like if I add a new one every time, that's gonna help out. I think so. We're up to 2 now, and it's just as long as they don't edit out my latest edition. So anyway, let's talk about this. I said that there's been kind of an evolution in the wastewater industry that has kind of changed the way we have to address some of these structures from a coatings perspective. And why don't we kind of talk about how the wastewater conditions have actually increased in aggressiveness?
Yeah, sure thing, Jack. So, many of the listeners today have heard a lot of these conditions, but it's worth really talking through again. But, really a lot of this began way back in the mid 80s when you and I were I would say just getting out of diapers, really, when Billy Idol was on the airwaves and Ronald Reagan was president. But one of the things that happened back then that really started us down this path was the elimination of heavy metals in the waste stream. And, prior to that, industrial facilities basically didn't have to pre-treat a lot of their waste before they sent it down the line. And
heavy metal, is that like Iron Maiden?
More like Slayer, but you got the drift there. But I know we don't play favorites with our metal bands here.
No, that was a reference to Bill and Ted. But yeah, you're seeing increased levels of heavy metals. Sorry for the pun. Continue.
No. So actually, like with a lot of regulatory, originally when that elimination of heavy metals was mandated, it was meant to be a good thing, which ultimately it was. But what we found out over time was that those heavy metals actually helped to curtail some of the biological growth in the waste stream. And so when you eliminated those, now it allowed some of this biological activity to really pick up. And add to that some other effects. One of those being a lot of municipalities started utilizing odor control covers, to try to enclose hydrogen sulfide gas to try to eliminate odor complaints. That was one thing. Some other things we started seeing is you started seeing more regional treatment plants, and so now you had longer detention times. Because let's face it, I mean, I don't know, maybe you're different than me, Jack, but we typically don't want to see a wastewater treatment plant, which maybe I want to see one more than others do because, obviously we sell coatings into those places. But I would say the vast majority of the general populace does not want to see or smell a wastewater treatment plant.
Yeah, no, definitely not. And I think, I think one thing I want to press on before we get too far down in this wastewater thing is we talked about the elimination of heavy metals. And I just want people to realize that if you think about everything down from like the deodorant that you put on to clothes that are meant as antimicrobial to different coatings or different things, even the different anti-fouling coatings, those are all utilize some sort of metal to prevent some kind of growth. So if you remove those from the streams, then there's no natural way to check the growth.
That's a great point, Jack. And and you combine a lot of this together, these longer detention times, this elimination of heavy metals, this, biological activity now that's really unchecked. We've seen wastewater get more aggressive, and hence it's led to higher levels of biochemical oxygen demand, or BOD, as wastewater operators commonly talk about. All that really has led to higher strength wastewater, and ultimately has led to more septic systems, which in turn has led to more corrosion.
Sure. I mean, and then doesn't that affect the flow within the system as well?
It can. I mean, and that's the thing is we've seen over time, more turbulent wastewater flows, basically from multiple lift stations in series or discharges at force mains. And what ends up happening is you end up having, in these turbulent flows, you end up having hydrogen sulfide gas that gets stripped out of solution and in turn can cause corrosion, to whatever the substrate may be. In a lot of cases, this is ductile iron.
So what is it about the ductile iron that makes it the choice for these wastewater piping and such?
Well, Jack, as you know, where I live and where I'm currently sitting today, Birmingham, Alabama, is actually the home of ductile iron. It's where a good portion of the ductile iron in the United States is made. But I tell you, when ductile iron got introduced, it got introduced back in the 1950s, and it was a definite improvement over cast iron at the time. Not getting into the metallurgy and really how it's made and all that, but just wanted to talk about the benefits of ductile iron. Is it's typically has higher strength and increased corrosion resistance when you compare it to cast iron, and then also to other types of piping. And the way coatings come into that though is ductile iron, because it is a ferrous metal, it is susceptible to corrosion. And there's stats out there that talk about the lifespan of ductile iron, and in aggressive environments, without a coating or some sort of other measure with that ductile iron, the service life is typically cut in half. And so coatings and ductile iron, I would say, go hand in hand, especially in these more aggressive systems, more aggressive soils, and so on. So today I think in our conversation we'll talk about some other substrates, but it is important to note that in our wastewater systems here in the U.S., the vast majority of the piping is ductile iron.
Sure. So let's get into a little bit about some of the, we've talked about how the systems have changed, that, we pulled the heavy metals out. We're seeing higher BOD levels, the turbulences, the abrasion could be up. As we know, those BODs can attack and create corrosion themselves. So, traditionally, we've treated these with a certain type of coating technology. And what are some of the limitations when we look at the traditional coatings that are used in protecting that wastewater piping?
You can kind of look through history, Jack, and look at some of the different coating technologies that have been used. I mean, anything from coal tar epoxies, Novalax, even some hybrid type technologies, in some cases vinyl esters. What we have kind of found over time is really two things. So I would say from a chem resistance standpoint, for the longest time, we were really trying to address these changing conditions with linings that would hold up to the chemicals. And so, tests like the Redner test or the pickle jar test, those were things that were commonly used to try to be able to see if your coatings could hold up in those types of environments.
Right.
What we started to find over time, though, because we started seeing a lot of these different coatings failing, it was less about the chem resistance, but it was more about the permeation resistance to sewer gases. And so that really led to some industry tests and some other research that we'll talk about here in a moment. But that was one thing. And then I would say that the second thing is we started seeing more erosion. We started seeing more physical forces in these systems. You now had wastewater that had to travel longer distances. In some cities, you have combined sewer overflows. So you end up with a lot of other objects in the sewers. And so you end up having to deal with, or you need to be able to hold up to impact, abrasion, erosion, cavitation, and a lot of those physical forces on top of having to have that permeation resistance. And what we were seeing over time is these older technologies that have been used over time just weren't really holding up quite as well as they used to.
So these challenges really did cause us as an industry to really kind of go back to the drawing board to actually, address the problem at hand. And that's that these newer abrasion levels, chemical levels, and things like that were actually causing problems with the older technology.
Yeah, that's definitely correct there. And I would say it really caused us to look all throughout the wastewater infrastructure, not just transmission piping. We're talking about in manholes, we're talking about at treatment plants, really the full infrastructure system there. And I know there's been some studies. I know NASTIT did one all the way back in 2002 that I believe it was updated when around 2016, I believe, Jack, where they were saying that, the cost of corrosion in the water and wastewater sector overall is about $58.5 billion.
Yeah, we know that that's even higher now. Things hit the news in the public sphere about investment into infrastructure, specifically in the water wastewater area. I think there was recently something that even specifically addressed water waste above and beyond the additional. So, and we've talked about in this space the report card and of the infrastructure, and as it gets older, you can only, prices don't go down, We've seen record inflation since that report came out. So really, that number has to be, what I'm getting to is that number has to be a lot higher today.
And one thing you maybe referenced there, Jack, I think there was an impact study that AMP did in just before 2020. And in that, they were talking about, the cost of corrosion worldwide was about 2.5 trillion. And that they were saying there was roughly about 1 million miles of corroded water and wastewater pipelines that would cost about 2.1 trillion to replace. And I think that's based on just their design life. And so,
I would lay 1 million miles in. I could lay 1 million more just to get all the wastewater to the plant and away from your door. La da da. Wow. It's Friday afternoon. We're recording this, people. I hope it brightens your Monday morning. But why does that matter? So we look at all this. So what are we needing in our core features? We know the problems we need to address. So how are we going to address those with the coating?
So we know, number one, that we need something with better barrier properties, that has that permeation resistance there. And so that was one thing. And so going back a few years, like I said, this was an industry coalition that really set out to try to find out what was happening in the wastewater infrastructure, and in turn wanted to develop coatings and linings that could hold up to these changing conditions. And so through that industry coalition, the product of that was basically ASTM G210, the SWOT test that I would say many of our listeners are very, very familiar with. But it was this SWOT test that really saw the birth of a lot of the different coating types that we're using today, with this next generation ceramic filled epoxy being one of those coatings that came out, or coatings and linings that came out of that. And so when you look at these next generation ceramic filled polyamine epoxies, number one, they have this unmatched H2S resistance. And so,
right.
So they can hold up to this SWOT test, which is a very aggressive 28-day lab test, involves immersion, vapor phase, and various aggressive agents, basically that are designed to duplicate the aggressive conditions in a sewer headspace. And so, what we've seen with these next generation materials is they hold up well in that SWOT test, and more importantly, they have that very top-notch permeation resistance.
So would you say these coatings really help prevent another pipe biting the rust?
The puns just keep rolling today, don't they?
Dude, they're Friday. We'll have to see. Maybe some of our regular listeners will text and say record them all on Friday afternoon. You'll never know. All right, so there's also some newer practices that are going on with cleaning, right? Like high velocity jet cleaning that these coatings need to be resistant to.
So at the municipality level, once the pipeline goes in the ground, the municipality has to maintain it, has to clean these lines out. And so the EPA actually has a program. It's CMOM. So CMOM stands for Capacity Management Operation and Maintenance Program. Yeah, so this basically this hydrocleaning process that's defined under that EPA program, you know, what you're trying to do is remove fats, oils, and greases and blockages out of the line, which allows you to basically go through and do routine inspections. And so what we see with these cleaning methods is you have fairly high PSI and then a fairly long dwell time. And so some of these first generation lining materials that we've been seeing used for many years can't hold up to the common cleaning practices that many municipalities are using. And so these next generation materials have gone through the testing. And I mean, you're seeing things like, pressures up to about 2,500 PSI. You're seeing jet nozzles with about 30-degree angle. In some cases, even 0-degree angle.
Wow.
and a dwell time of about 60 seconds. So you're talking about some pretty intense pressures on some of these linings. And so being able to have something that can hold up to that is very imperative.
Yeah. So, we've talked about the individual problems within, we're creating abrasion, not only with the particulate matter that's in the stream, the H2S that we know can lead to ultimately sulfuric acid when it comes to corrosion creation, and then this high velocity jet cleaning. All of these are the problems that these next generation coatings need to solve. And it seems, how do they solve them, Brian? What features of these coatings specifically address these problems?
Well, we've talked about with the H2S, we've talked about the permeation resistance, number one. That's one key feature of these linings. The fact that they utilize a ceramic filler helps with the abrasion resistance. We didn't even really talk about some of the testing that these products go through. I mean, there's basically a what's called a rocking abrasion test, where you line a pipe and you basically put all this abrasive material in the pipe in a slurry, and you rock the pipe back and forth. And I'm talking about an insane amount of cycles. And these linings have to be able to hold up to that. And so these next generation materials have indicated through these tests that they can hold up to the most abrasive conditions. I would say some other features that are very vital in these next generation materials. One thing that we haven't really touched on as a problem is the above ground storage life. And so let's talk about an infrastructure project. So often the pipe will get fabricated and then lined in a facility, shipped out to a job site, or in some cases it may sit on a storage yard for a while. But often there's going to be a lag time between the time the pipe is lined and when it goes in the ground or when it goes in the plant or wherever it's getting installed.
You mean that's not immediate?
It's not immediate. Yeah,
they don't just Captain Picard that right over there. They just right in the ground, Fantasia style.
That would be nice, but
it would be.
But when you look at these first generation of the older technologies, a lot of them had coal tar in them, and so what would happen is these pipes would get lined, shipped to a job site, sit on the job site for forever, and often ductile iron pipe has an asphaltic coating on the outside. So you've already got a black stick of pipe sitting on a job site that's going to absorb heat. And you've got a coal tar type material on the inside of the pipe, which is basically going to heat up and then desorb. Over time, you're going to end up with cracking. And so a lot of your first generation linings out there had a very short, what we call above ground storage life. These next generation materials are more resin rich. And so they don't have near that level of drying out. And so we're seeing the Tnemic product in that space, Series 431, we're seeing above ground storage life values of up to 7 years. And so if you're an owner or even if you're a waterworks distributor, being able to have a lining that can, basically if it's a fitting or stick of pipe, that can be lined and then stored on a job site or in your facility for longer than a year is very important. Because otherwise, once that lining cracks, you've got to, in many cases, come back in, blast it back out, reline the pipe or reline the fitting or whatever the component is. And so that's another, I would say, very key feature of these next generation materials. And as mentioned, the Tnemic product that fits into that Series 431 Perma-Shield PL.
The Perma-Shield PL, yeah. And you know, I think you had an uncle PL or something like that you were telling me about.
I did. Being from the South, you know, we have some interesting characters in our family. And a few years ago, complete sidebar here, but a few years ago, I found out I had a great uncle by the name of PL. When I started inquiring about what PL stood for, I realized that it stood for nothing. His name was literally 2 letters. So take that for what it's worth, Jack.
Maybe because you struggle with rural, your uncle's name was plural, and nobody could say it, so they just shortened it.
We just shortened it? Yeah, that's a good point. I think you may be onto something there.
But anyway, these ceramic epoxies, they're not all created equal. Tnemic's definitely has this longer storage stability after it's on the pipe. That is not true of all manufacturers, and I would ask, if you're looking into a ceramic coating for the inside of your pipe and you are going to store it for any point of time, whether you're a pipe distributor, whether you have some time between construction, to make sure that your manufacturer can assure you that you can store that pipe if there's any kind of delay between the application of the pipe and the installation of it in the final service life area. So there are some other long-term benefits. Let's talk about long-term benefits of these types of coatings.
So I think to talk about those, that there's a few other key features that I would say lend themselves to those. The fact is that the Series 431, it can be inspected per the common industry standards for high voltage holiday detection. Other linings out there cannot be. They recommend low voltage holiday detection. And so that's important for longevity. When you're talking about being able to have a holiday free, pinhole free surface, especially on the inside of ductile iron pipe, is very huge there. Another thing from a municipality standpoint, Series 431 comes in a color sewer pipe green. And we've had excellent feedback over the last several years from municipalities talking about how when they inspect their lines, being able to camera these, the green shows up so much better. So it allows them, when they come in to do routine maintenance or when they come in to do hydro cleaning and then inspection afterwards, everything shows up very well on camera. And so that, coupled with all the other benefits we were talking about, lends itself really to longer service life. And when you look at all the different options out there, you got to think with pipe, it's a out of sight, out of mind thing. You know, you want to put this pipe in the ground and not have to worry about your infrastructure for the foreseeable future.
Sure.
So let's face it. I'm sure you live in St. Louis there, Jack, and driving around town, when you've turned the corner and tried to drive through a street and they've got the street dug up because they're having to replace something. They're having to replace pipe. It's a major inconvenience. And so
they've been doing that on my street all year. It's been kind of hard to record a podcast.
I can believe it. And so it's a major disruption. And so if you look at that in the terms of sustainability, being able to have a lining option that you can line your pipe with that you don't have to worry about over time, it is crucial if you're a municipality, because now you don't have to disrupt your community basically by digging up faulty lining or faulty pipe over time.
So Brian, we talked about ductile iron pipe, but there's obviously other places that these new advanced ceramic coatings could be used. Do you want to hit on those real quickly?
Yeah, I'd be happy to, Jack. You know, we've talked about a lot of features and benefits of 431, and what we started finding was we had some really good adjacent markets where these performance characteristics fit in very well, also. And so one of those was steel penstocks.
Okay.
In some cases as an OD coating, but we've even used it as a lining in some of these higher velocity penstocks. And so when you look at a steel penstock, cement mortar lining has a lot of limitations. If it's higher velocity, they typically can't cement mortar line the pipe, and so they have to look at a more abrasion resistant lining. And so we found a great use for Series 431 in those cases for raw water. We've also seen it used a lot in, if you think about, in a lift station, you may have exposed piping. And so being able to have a barrier coating on the outside of your ductile iron pipe that's going through a lift station is also very beneficial. And so we found that the permeation resistance of 431 lends itself very well as an exterior coating on pipe in some aggressive environments, such as a lift station or a vault.
For sure. So these technologies, obviously, with their great abrasion resistance and application tech abilities and chemical resistance and things like that, their low permeability are bringing in a whole bunch of new uses outside of just that ductile iron pipe. So, Brian, thank you very much for coming on the show and showing us how the industry has, and even just the environment and the world we live in, has shaped how we develop coatings, how it's changed the industry, and how these new ceramic-filled epoxies, especially Perma-Shield PL Series 431, are reshaping how we think about coating these assets. Thanks again for coming on the show, Brian.
Jack, thank you for having me. Enjoyed that conversation. And I'll tell you, it was a bonus to hear all the puns, the bad 80s references, and the discussion about my Uncle PL. So that was all bonus in my book.
Well, there you go. Well, thank you very much. And for all of you listeners, thank you very much for taking your time to listen to us about this subject. And we'll see you in a few weeks.